Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments, where tonight we'll take a look at some activities which can help math supervisors and coaches to strengthen content knowledge with TI technology. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first Q-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Judy Hicks and Betty Gasky. Judy, who lives in Colorado, taught high school mathematics for 34 years in the Denver area. As a T-Cube national instructor for Texas Instruments, she is dedicated to helping other teachers learn how to effectively use educational technology in the teaching and learning of mathematics. Judy has authored numerous textbooks and is active in state and national mathematics organizations. She also received the T-Cube Leadership Award in 2014. Thanks for being with us, Judy.
Thanks, Mike. Even though I'm from Denver, I'm currently tonight in rainy Wisconsin.
I'm glad you're still with us. And Betty taught mathematics in grades 7 through 12 and also at the university level for 28 years. She's a T-Cube contract instructor and has served on numerous Texas Instruments professional development writing teams. Betty enjoys working with math and science teachers to help them more effectively incorporate technology into their classrooms. She has conducted trainings for teachers in not only the United States, but also Asia, with a recent focus on TI-Nspire technology and the TI-Nspire Navigator system. Thanks for being with us, Betty.
Thank you, Mike. It's great to be with everyone tonight.
We are expecting a large crowd, so your audio is muted. Feel free to send questions to Betty or Judy using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. Once we move to the software, that right section of your screen will be replaced with a green floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available, if you'd like to follow along with your handheld or your software, and we truly hope you will, we do recommend doing that with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Judy is going to discuss our agenda.
All right. Thanks, Mike. All right, the agenda for tonight, we'll skip the first one since we've done that. But what we want to try to do tonight is go through a few activities that develop students' content knowledge, as it says. Betty and I are both, as part of our job, we do some coaching, and we also work with coaches and supervisors. And so we've seen some concepts that have either been added as new ones or have been moved from grade level to a different grade level, particularly in the Common Core Standards and also in the TEKS. And for you non-Texas people, that is the Texas Essential Knowledge and Skills. So some of these content-specific activities we're going to try to do tonight are some stuff with data and statistics with box plots, and also another activity called Square It Up. We're also, with those, going to talk about NCTM's principles to actions. If time permits, we're also going to look at building concept activity, and 2 of them listed there, although there are 15 of them, which we will point out. And Mike's going to talk about some free online resources, and then right at the end, we have a drawing. Excited.
Thanks so much, Judy. It is exciting. And I think, Betty, you're going to discuss our expected outcomes.
Yes, and as Judy said, we are going to be looking at some activities, and they will be both for the TI-84 Plus family of graphing calculators as well as for TI-Nspire technology. And again, our focus is on helping educators strengthen their knowledge of the new standards and to support the implementation of these standards if they're new for the teachers or if they've moved to another grade level and the teachers just simply haven't taught them before, or if they're new educators and your U.S. coaches or whatever your role might be. Strive to help these teachers. We're going to share some great resources.
Thanks so much, Betty. And Betty, it's all yours.
All right, great. Let me share my desktop, and then we're going to turn it over to Judy to talk for a few minutes while we look at some resources, getting started right away.
All right, thanks, Betty. As Betty is showing you, she's going to do most of the driving with the software tonight, plus she's going to be talking, but we both kind of tag team on that. So please feel free to ask us any questions, either one of us, and one of us will try to respond, or Mike will. So the first thing that we thought we would look at is an activity on box plots. And so we're going to get this in a different place than some of you might think. We're going to go to something called Principles to Actions. Now, what Principles to Actions is, NCTM created this publication in 2014, and NCTM and Texas Instruments have partnered on this. And there are a couple of activities, as you saw on that last one. Now, what we wanted to show you, first of all, is what this publication looks like. And what this is strategies for teachers to engage students in mathematical thinking, and these are the 8 teaching practices. Now, before, in some other webinars, we've talked about the mathematical practices, but if you just take a quick look through this, we're going to really focus on, even though the activities we're doing tonight really have all of them in them, but we're going to focus on number 2, implementing tasks that promote reasoning and problem solving, and also the one about using and connecting mathematical representation. And as we start to go and look at some of these, again, we cannot stress enough the importance of data interpretation. So what Betty is showing you now is, so far, Texas Instruments has gone through and have taken 4 math-inspired activities and enhanced them. And so the one that we're going to go through and show you how that looks a little bit different is the box plot introduction. So those of you that might be familiar with that, you may not have looked at this particular document, because as this starts to go through, besides the regular math objectives and learning goals of students describing the overall pattern of a distribution by its shape, center, etc., but as Betty starts to peruse through this, you'll notice that some of the information is going to be a little bit different than maybe what you're used to seeing. So again, as she's going through this, here's about the lesson, the vocabulary, and all of that. Now this is where, in the italics, is where the principles to action really start to have some focus. Because now, and we won't read that to you, but we would really invite you to look at this in more detail. Because now it's going to help the teacher with these teaching practices. So as Betty's going through this, you'll see throughout this document, you're going to see these things. So it really helps us right there, elicit and use evidence of student thinking and things that we should be able to do. All right, so let's go, and so again, please go through and look at this at some point. Okay, on the TNS file that Betty is showing you right now is where we got that. Again, you saw that, but here we have 28 heights of kids. So when we move to page 1.2, we're going to see the box plot as well, the box plot as well as the dot plot. Now, I'm going to ask a question that I would like you all to chat and answer to. When you do stuff with kids with box plots, or when, as coaches, when you're helping with your teachers, what is a misconception that students might have about a box plot? I'll give you a second to send something in. So if you could chat something, when kids look at that box plot, what are they likely to say when they first see that? Why do we have to know this? Okay, that's one thing. Somehow averaging is taking place. Good.
And the one went by a minute ago, Judy, did you see that about the larger quartile meant more data, students might think?
Right, there you go. That as we, especially that whisker on the end there, that kids, exactly, and most of you are hitting that right now. And, you know, how come there are only 2 whiskers, and why isn't the meeting in the middle, and all of those good questions. So what this activity enables us to do is to get some of those questions answered. And that all the, okay, I like Kim Brown's here saying that all the data is in the 3rd quartile, et cetera. So Mike's saying, I did this with my students yesterday, and almost all of my students saw that. So just exactly what we were saying. So what Betty is going to do, and again, even if you go through and do things with students as far as creating, you know, life type of box plots, that's what I used to always do with my kids. But at some point, the technology is a way for them to do this visualization. And as I mentioned earlier, there are publications that we've been seeing for years that just to be a good citizen anymore, you need to be able to understand and be able to interpret the way the data is displayed. So as Betty is hovering here, it is showing those 5 values. So as she goes along there, and again, this is where, and if she clicks in one of those, you can see what happened with the dot plot. So just from looking at that, what information, and again, just a chat question here, what information does a box plot provide that a dot plot does not? So what can I get from a box plot that maybe I cannot get from a dot plot? So what do you think? Okay, range in numbers within a section, good. Median value. All right, so again, outliers, good. So all of those kinds of information, and this is according to the principles of action, this is where we're asking those purposeful questions of kids. So again, all of those kinds of things that are coming in. All right, now to continue to facilitate meaningful mathematical discourse with kids, and again, looking back at some of those things, now what Betty's going to do is she's going to drag one of those points in the dot plot. Now, what has happened now in the box plot? You can check that answer. So by Betty going in and dragging one of those dot plots, now we have an outlier, right? So again, these kinds of things just allow us to make all of these, you know, conjectures, if you will, but then we can start to talk about the mathematics. So now, again, in the student activity sheet that goes along with this, it actually goes through and says, all right, now how do I determine an outlier? So then we can get into the mathematics of that. What would I have to do to make the data be skewed you know, all of those kinds of good questions that kids can go through and really visualize with this. Okay, Mark is asking if this is 7th or 8th grade. Great question. When Betty and I both looked at the Common Core as well as the TEKS, information about box plots, histograms, which we're going to get into next, dot plots, actually started in 6th grade. Thank you, Marge. And different pieces of it actually even went through high school. So
and the dot plot was, excuse me, I think the dot plot was also included in the 7th grade as well as 6th grade in high school.
Right. So again, kind of depending on if it's Common Core or TEKS, but it is definitely there. Now what Betty's going to do, since she moved some of the data, she's going to hit the reset to set it back. And now another nice feature. So we've gone through, we've talked about the median, we've talked about all of those kinds of things. Now the next thing that we may want to see is where the mean is. So Betty's going to go over and press the menu key and go to Analyze and choose number 8, Plot Value. And now she can just type in the mean.
And Judy, you'll notice I'm on the lower part of the screen, so I might want to go do this in the upper part of the screen as well. And this is a data set called height. So that will plot the mean value. And then if you wanted to do it on the box plot as well, it would be exactly the same steps. Analyze, plot value. And it's treating it as a second variable, but it would still be the mean.
Right. So now we can look at a little bit different representation as to, okay, when we look at the mean, what did that have to do with the median? Because as somebody mentioned earlier, one of the misconceptions with kids is they always think mean and median are the same. And when are they, when aren't they? You know, all of those kinds of good questions we can talk about. So we could continue with this, but what we would like to do now is show you a similar activity with the 84, because we know that there's a lot of people out there using 84s as well as Nspires. So first of all, Betty's going to go back to education.ti.com.
Okay, and Judy, one moment, but I thought I saw something flash by in the chat a few minutes ago about the outlier.
Okay, good.
When we move this over and it becomes an outlier, the formula that students work with is that they find the interquartile range. Many of you have dealt with this, and then there's a certain distance that this point has to be greater than 1.5 times the interquartile range away. And that's explained in many of the teacher notes, and if you haven't taught that lately. But then you notice when I moved it back, suddenly it was not that distance away that it needed to be an outlier. So I'm going through that awfully quickly, but the mathematics, as Judy said, can be done, but it's such a wonderful graphical display to go along with the mathematics so that students can see when it does become an outlier and fit that in with the mathematics. So the graphical as well as the analytical.
Good.
So,
good.
And so we're moving to the 84, but before we do that, we're going back to education.ti.com, as Judy said.
Just to show you where this activity is coming from.
So under
and
activities.
So we're going to go to activities 84 Central, which is a fairly new part, so some of you may not be familiar with this. And the activity that we're going to look at is actually in Algebra 1 as well as in middle grades. It's the same activity on box plot and histograms, so that's where that's coming from.
So this particular activity. And what we did earlier, we put some data into list 1. It's not exactly the same data that you would find in that particular activity, but it's a data set to be able to graph. And many of you have probably graphed box plots before with the 84, but if not, it does a very nice display. And since the data are in list 1, we're good there. And if I simply do a zoom to the data, or Zoom stat. Notice the x-axis is not affected by the Zoom stat. Okay. And let's see, Judy, what next? Add the histogram?
Sure. And just like before, while Betty's doing that, we can also trace on the box plot, but let's get the histogram in there first. So this one is going to go through and ask some of those similar questions about, you know, what are the differences between a box plot and a histogram.
Now, obviously, we have to do some window adjustment.
Right, right. But these are all good things for the kids to do, as well as to say, okay, what do we have to change here to make that representation easier to see? So while Betty is changing some of the window, is what information, okay, another chat question, is what information does a histogram give me that a box plot does not?
Okay, sorry, I was had frozen my emulator there for just a moment, it looked like. So one thing that Judy did mention when we were talking about this the other day, that some of you may need to remind your students, when you're doing a histogram, the X scale is actually the width of the bars.
Right, or the bins, a lot of books.
Yes, the bin
width.
Right. And then we're going to try to add enough space to the vertical so that we can see both of the plots without them being on top of each other.
Right. So the question that I asked is some of the things are coming in, frequencies of each data point, specific concentrations, good. And Leslie said she likes 84 for the regression equation. Haven't figured out how to do that with the Nspire. Well, hang on to that thought.
It's coming soon.
All right, so on the 84, and this is the latest emulator, which isn't quite out yet, but now, as many of you were mentioning, now what we can do is, again, we can go through and ask those good questions as to what's the information. We already talked about what's the box plot doing, and what is the information that the histogram is doing. So similar to what we did with the Nspire, now let's go over and let's do a vertical line to plot the median. So first of all, Betty's going to go up and see what the median is. And we can see there at the bottom that the median is 62.85. Now there's a couple of ways to do this, and we thought we would show you both ways. So Betty's going to go to the draw menu. Excuse me. And then choose vertical. And now, just with using her arrow keys, she can go through, and we were going to plot the median. So now we can see a little bit more visually where that median is in our histogram. Now there is another way to do this, but first Betty's going to have to hit clear draw. Because we noticed that this question came up in last week's webinar, so that's another reason we thought we would kind of go through this. So this time she's going to go back to the home screen, just so you can see some of the different things. And now again, choose draw.
Oops, sorry. And vertical again.
And vertical, number 4. And then actually put in the number, the 62.85, the exact value that we got from the box plot. And that's another way to plot that. Now, we could do the mean the same way. We just chose to compute the mean first. But we just decided we wanted to show you both of those ways.
And many of you would recall that you can compute the mean by going to second stat and go into your math operations. But again, that would work the same way. Right.
So we wanted to show you a little bit about stats with box plots, histograms, and so forth, both on the Nspire and on the 84. So what we're going to do now is do another activity, and Betty's going to bring this one up, and it's called Square It Up, but first we're going to show you where that comes from.
Okay.
So Betty, I'm going to turn over the talking to you.
All right. Thanks, Judy. All right, so we're going to go back to the Inspire, but then we'll visit the 84 again in just a few minutes. And this particular activity has to do with bivariate data. It's called Square It Up. A lot of teachers have not dealt with residuals, and of course that's included in the Common Core, and it's taught now when many people are looking at regression models or just simply fitting models to data. So we're going to go back to education.ti.com, and under the activities, go to Math Inspired. And there's a statistics section that if you're teaching middle grades math or Algebra 1 or working with those teachers, I would still suggest that you visit this because we've got the univariate data, and there's still some great activities for younger students, not just high school AP statistics students. And then we're going to go down to describing bivariate data. And this particular activity is called Square It Up. It lives right there. And we've already got it open in the TI-Nspire software. So in this data set, we're looking at life expectancy of people over a 104-year time period. And again, all of these data activities are very much real-world connections, which is great as well. And the lists that are involved are the years involved from 1900 to, I believe it said 2004. So it goes by tens at first, and then it switches to going by 1, 2, 3, 4 for 2004. And then you've got the life expectancy of people, men separated and women separated. And so we're going to actually go and graph these data. And there's already a data and statistics page that had been added to this document, but had it not been there, we could have inserted one. So obviously we would ask our students what should be the independent variable, what should be the dependent variable, and why. But in this particular case, I think most of us would choose time, this case a year. And let's first of all just look at the data aggregate, the person or the people. And what I'm trying to train myself to do when I work with students is to do what a teacher friend always does with her students and says, okay, let's pause for just a moment. What do you notice? Or what do you wonder? So if in the chat window, if you would contribute a what do you notice thought, or what do you wonder about with respect to this graph. So we'll give you a couple of minutes to share something there. All right, life expectancy goes up, looks reasonably linear. Mark, I think I missed yours as it went by, positive correlation. What happened in 1970? That would be a good question.
Oh, that is good.
Clump of data in the later range. Remember, we had those 4 years clumped together, but definitely, yes, it looks like more than 4. Okay, great. So this is, oh, yes, what happened in 1950 as well, when things did not keep right on going up. So again, this is life expectancy. So before we go to actually what we were planning to do, Judy and I thought it would be neat to show you something that the TI-Nspire can do. Notice we've got 3 sets of data related to year. So with the TI-Nspire, you can add additional Y variables or additional X variables if you choose to, without doing 3 separate graphs on 3 different pages. So we're going to go to plot properties. I'm going to choose add Y variable. And now I can add the men to the graph. And notice the icons let us know which is which, of course. And then we can go back and do plot properties, add another Y variable. And this time I'll add the women to the graph. So we can see how they're separated and compared to the aggregate person. So kind of interesting. I did this one time with gasoline prices from about 8 different countries over the same time, and it was pretty interesting. So we can remove those as well if we choose to. And in this particular case, I'll go ahead and remove those that we had added and just keep person. Okay. So someone said they thought it looked fairly linear, and someone mentioned they had not done a linear regression, so we're going to go ahead and look at how easy it is to do that. But before, we're actually going to do something really nice for the younger students, and under Analyze, we're going to choose Add Movable Line. And this lets students actually grab, and with the handheld, they would hold down the click key for about 2 seconds, and rotate or translate their line to try to get a good fit. So this gives them a chance to fit the data without, first of all, popping into regression, and talk about the characteristics of a good fit. Some data points above, some data points below, that type of thing. But they also have an opportunity to look at residuals. And even if they're not very familiar with residuals, it's something that the teachers can talk about with the students. So I'm going to show the residual squares. The TI-Nspire allows us to do this. And students,
excuse me, Betty, this is a topic that a lot of teachers have not done with the residuals and the squares.
Exactly, and may not even be comfortable at first with what the residuals are indicating. So I always try to find an example where, for example, this little data point, the second one from the left, and let me move this over. It looks like the Y value there is 51.5 years at that second data point in 1910. But if you come and look at what is being predicted by the movable line, it looks like it might be 54, 56, around 56 years. So the the movable line is actually over-predicting there, where it might be under-predicting for some of these. So the difference between what the movable line predicts and what the actual data value is the residual or the error. And then the square, the geometric model, the sum of the squares tells you if your model is pretty good. Lower sum of squares, better model, because you're closer to all of the data points. Now the neat thing with the TI-Nspire is, of course, we can show that for our movable line, but then if we choose to, we can also remove our movable line, and at the point that you would think would be appropriate for whatever you teach, go into the regression equation. So I'm choosing Menu, Analyze, Regression, and then we have all of these different models. So we'll start with the first one. Now, in this particular case, it still looks like pretty good fit. Some data points above, some data points below. If I go and look at our residual squares again, the students would find that this would be a lower sum of squares than the ones they likely would have done with their movable lines. So our regression model would minimize the error. But what's also interesting, and we're going to do this next step in just a few minutes with the with the 84, we're also going to look at the residual plot. And with the residual plot, we're keeping the X values the same, but we're actually going to graph the residuals themselves. In other words, right here, the difference between the observed value and the expected value from the regression. So I'm going to go back to residuals, but this time show residual plot. Now, in general, residual plots should be random. The data should be random and small if your regression model is a good fit. And I think most of us would agree that there seems to be some sort of pattern there. So this is good information that we're given by the residuals. The R value doesn't always tell us as much about what we might not want to know about the fit of a regression equation. So again, we can actually do this. Some of you may not have done it before with the 84. We can do our residual plots fairly easily, and we'll look at that in just a moment. But if I insert another page and do the graph of the same data set, just wanted to share this, the year again, and the person, the activity actually has students trying to consider, since they did not get random residuals, it actually has them consider what model might work better if linear does not. And if you think about it, going back here for just a moment, or actually let me stay on this page. If I start changing the scale a little bit where we're looking here, do we really expect that as the years go by for this life expectancy to get greater and greater and greater? Because if you kept the linear relationship, it would kind of indicate by the time you got to the year 2080, we might be up to 100. Oh, okay, a question just came. Yes, so Mark's saying it will probably plateau. I will get back to the R question, and let me do that very quickly. If you've done a linear regression, for example, you can insert a calculator page, control document as add page, add calculator, and then when I press the variable key, there are lots of variables here that are related to the regression equation, and stat R is the R value, and as you'll notice, it's fairly high. But again, that residual graph tells us something else is perhaps going on. So if we go and graph, let me go back to the window that we had originally. If we actually go back to our regression, and the leveling off, this is again not something that you would teach in middle school or even Algebra 1, but the logistic model is often explored to think about things that have a limiting. In other words, we know it's going to level off. So the life expectancy would certainly level off, and as x gets greater and greater and greater, the denominator would head towards 1, and we would see that limiting factor in the numerator. So this would be something for higher level mathematics, but I think it's adequate when we're with the younger students to talk to them about the fact it's not logical that this linear model would continue onward and onward just because of the life expectancy situation. So the TI-Nspire's got lots of nice features for exploring that type of thing, but we can also, with our 84,
Betty,
yes.
Before you leave that,
yes,
maybe show the residual plot for the logistics.
Oh, good idea. And when we go, as soon as you run a new regression, the R value, if one was computed, it would not be for the logistic, but if you had run a second type of regression where the R value was computed, everything would be updated for the latest regression that you ran. So as we see, we've got a much more random looking and certainly smaller values as we look at these at the end there. So the residual plot, as someone just commented, certainly does provide important information. I have graphed data that were clearly quadratic and run a linear regression and found that my residual plot was curved to hint that it should have been a different model. So it does give lots of interesting things to talk about with students. Thank you, Judy, and thanks for all the comments all of you made. Now this data set I actually put into a little program just so that we could get it graphed very quickly. And this is that same data as you saw a moment ago, and the independent variable is still year, the dependent variable is person. And if we wanted to do the movable line, some of you may not have played with this, but the 84, if you go to Stat Calc, that manual fit is like playing with the movable line on the Nspire. It's just a slightly different variation, but at least it gives students a chance to fit their own line. But if we were going to run a regression, I'll go back to Stat and Calc and perhaps choose the linear regression option. And it will use L1 and L2 unless you change it, and that is where I had put that data set. And then we can store the regression equation. If you press alpha followed by the trace key, you can choose the location to store the regression equation and then just calculate. And again, there's that R value we talked about a minute ago. And then if we graph, we'll see the same regression equation. Now, to look at the residual plot on the TI-84, it's not helpful to show it in the same window because the scaling is so different. So what I typically do is turn off the regression equation temporarily in case we need it later by entering on the equal sign. And then when we go to the plot, remember with the residual plot, our x values were the same, our independent variable values, but the y values were the actual values of the residuals. So with your TI-84, every time you run a regression, those residuals are computed. And if we press second stat for list, the residuals are stored in a list called resid. So I'll select that and then zoom to that particular data set by pressing zoom 9. And those are the same residuals we saw a few minutes ago with the Nspire. So again, indicating some sort of pattern and perhaps not as random or as small as we would like to see. So this does give some capabilities of talking about these residuals and also helping students understand that for different values, it would be the difference between what the model predicted and what the actual data value was, positive or negative, depending upon whether it underpredicted or overpredicted. So the observed value minus the value expected by the model would give us our residual. Okay. Anybody got questions, comments there?
Now, for those of you that have not done this part that Betty just showed you, there's lots of atomic learning videos that I think Michael probably suggests to people that take you step by step through this.
And again, the residuals are mentioned in the Common Core standards, but much of what we have done, if you had not done the residual piece of it, would certainly fit in with the recommendations to have students graph real data, fit models to those data, interpret what does it mean in a real context. And when we were looking at our first model here, Judy and I were talking about it, having the students interpret the slope and the y-intercept. So whenever the students are looking at, even if they don't do the residuals, if they're just looking at fitting a model to real-world data, always having them talk about what does the slope mean in the real context and what does the y-value or the y-intercept mean. And in this case, the y-intercept really doesn't tell us anything. We wouldn't be talking about year 0 with a negative 454-year life expectancy. But we could talk about the fact that this is about 1/4 of a year that the life expectancy seems to increase as you go up each year. So as each year increased using the linear model, the life expectancy increased by about 1/4 of a year. So again, the TI-Nspire activities give us lots of real data already entered in, so we don't have to have the students use our valuable class time to type it, and gives us an opportunity to explore some real data and fit those models. So there was a question about the atomic learning videos. Mike, is that something you're going to visit at the end of this part, or should we show that now?
I can take care of that at the end. That's no problem.
Okay. So the atomic learning videos, they're for a wide variety of TI technologies. Okay. Now, one thing that's new with TI-84 that Judy and I thought we would share for just a moment, if you do have the 84 plus C or the new CE, they have built in a new feature that we thought might be of interest. We'll just spend just a minute on it, and it's under second zoom format. And you'll notice if you've got an 84 plus, it looks a little bit different from this than the 84 plus C or the 84 plus CE. You can actually go in and change the grid color and create grids. The axes color can change, but one thing that's a really nice feature is these backgrounds, so that you can actually bring in images. There's some pre-stored images, but there's also will be a way to enter images of your own. So right now, if I wanted to look at this particular one, the sliding board, I could just press graph and there it is. And I can go ahead and zoom to whatever window I choose. Just pick one to put the 0, 0 in the center of the screen, the origin. And then there's a nice feature that they've added under Stat Calc where you can actually do a quick plot. So this allows students to fit a model to any part of the sliding board you choose. if I chose the railing there, I could press enter to drop a point. And yes, the axis could be moved, but not kind of in the grab and drag way that you would with the Nspire. We could just reset the axis settings. And then I could press enter again if I think that's another location on the sliding board handle, which of course parallels the sliding board. And notice after I've dropped 2 points, I have a chance to fit an equation. If I were going to fit a quadratic, of course, I would want to add at least 3. But the soft key, the key that's underneath the fit equation on the handheld, would be the graph key. So I would press that, choose the model, and in this particular case, it will show us the equation. And you could have students, again, interpret what does it mean to have a slope of about negative 37/100 in relation to the sliding board. And that equation actually could be stored as well to look at it later. So this is a nice new feature of the 84 plus C or the 84 plus CE. All right, Judy, I think we'll turn it back over to you here.
Yeah, just real quickly, we thought since we had done the image here in the 84 that we should also do it with the Nspire in case some of you needed to be reminded of that. So what we're going to do is just do a new document. And again, we'll just show you very quickly. So we'll put in a graphs page. And now if we go up to the insert at the top and choose image, it'll automatically, unless you change it, go to some preloaded images. But as Betty said, just like on the 84, you can bring in your own images, and kids like to do that. So there we have an image of a fence. And here again, we can, now the question earlier was about sliding the axis. So just by taking our axis and moving it around like that, we can study transformations of functions and we could also differentiate instruction, because we could have some kids have, you know, the origin there and other ones have it at the top, et cetera, et cetera. So now, what kind of mathematics could we do with this? Well, we could fit a line. We could maybe try to come up with an absolute value graph. I mean, just, again, this is where kids really start to excel as far as what kinds of things could we do with this image. So, again, we wanted to make sure you saw how to do the image with both of them. Okay. Now,
some great ideas, too, about that picture. And we'll think about that next time we use it. That's great.
Oh, somebody's mentioned there they don't have an Nspire, but how about using a smartboard and some kind of a graphing platform? You know, as teachers, we have to use whatever we have.
That's
and
exactly
I'm
right.
Sure we could, yeah, we could. There's lots of stuff that the smartboard can do as well as other graphing platforms. So, again, we do what we can. So, again, a comment from Leslie, it has parallel lines, transversal, all kinds of great things here. We could measure angles and do lots of things. Now, the other thing before we hand it over to Mike, we wanted to make sure we mentioned, since this also was supposed to be partially targeted to middle grades, but there's also something under the activities called Building Concepts in Mathematics, and Betty's going to show you that. And right now there are two parts to it, fractions and ratios and proportional reasoning. So this is what I was mentioning earlier, that there are 15 activities here that are targeted mostly for 6th grade to 8th grade. But when I've done this with some teachers, they said even some high school kids could benefit from some of these.
And Judy, while you're talking, I'm going to go ahead and show a couple of them and let you just kind of talk through them, if that's okay.
Yes, absolutely. So what we did is we went through and just picked out a couple, because once I'm going back to that whole multiple representation. So this is one that Betty and I both kind of look like. So it starts off giving you a ratio. And what most kids don't quite put together is the connection between all of these. You know, what does a ratio have to do with plotting points? What does plotting points have to, you know, and again, so you can go through, and what Betty's doing is she's just using that little keypad on the right-hand side, and now we can start to talk about slope. We can talk about, yes, Mark's saying we can use it as a review in high school, definitely. Because many kids, they haven't made that connection that really, when it comes down to ratios, what is going on? Why does it have something to do with this? So this is, now we just pick this. This is like the, I don't remember, in the line of 15 of them. Not that you have to do all 15 of them, but as Leslie's saying there too, slope is a proportion. So there is now for those of you looking at some of these, when you download some of these things too, there's a PDF that goes along with this that goes through and describes what each one of these things do. So you as the teacher or you as the coach can go through and say, well, my students really need some help here. Or maybe I have one group of kids that need to start off with that very first one, and other kids could, you know, move to. So you could really use them to differentiate instruction that way as well. And as Betty has shown you here, this one is, yeah, it's showing a great visualization for rate of change, because what Betty's doing is going through and clicking on the blue, I believe, right?
Right, and it'll also let you change the ratio if you choose to, and then just click on the blue arrow twice, and then again.
Yeah, and it's differentiating that whole rise over run, and I always jokingly say a lot of kids think that that's one word. But
indeed.
Anyway, so all of the things that we can use. Now, the one that Betty's going to talk about is another one of our favorites, which can be used even in geometry. So I'll let you talk.
And Judy was talking about the fact that this is great because it can lead us into some of the geometric concepts that we have to work with. And this particular one, the students are looking at similarity, of course, and they can drag the smaller rectangle and see similar parts to it, but also get into shapes and areas and that type of thing. So there are really lots of neat things in here, and then they can just choose a new area and see what happens as they drag them around and talk about relationships. And then another part of this one that we really liked is that they can click and do 3 sides and then let them try to determine the 4th one and see how they're related. So lots of nice connections with the algebraic and the geometric representations. And this one, I think, actually even gets into some areas as well. And the scale factor right now, they can show, or they can actually try to determine the scale factor before they ever show it. So it gives them lots of ways to work with it, and moving again into all sorts of wonderful opportunities to connect the algebra and the geometric concepts.
And, you know, taking this a step farther, there are so many new standards in both the Common Core as well as in the TEKS that have to do with transformations. And it's really different if you haven't looked at some of those geometry transformations, is because of how we now are supposed to show that triangles are congruent. Instead of the old days of starting off with something like side angle side, now we're using them to show that 2 triangles are congruent. We're using things like translation and so forth. So this can even though a dilation isn't necessarily a congruence unless the scale factor is 1, but it's a great intro into some of those things as well. So even though these were sort of meant for middle grades, I think that they have some great things for high school as well.
And as someone said in the chat, and as Judy commented, sometimes we just need to review these concepts, and these are excellent ones to do it with. So we wanted to look at some univariate data with the box plots and interpreting those data sets and thinking about the different representations and when is one representation better than the other. But again, having students fit lines to real data and interpret those lines in a real context, and as well as sharing some of these new activities with you. And again, those concepts that some teachers have not taught, and the technology certainly does help, such as some of the similarity work, or, as Judy said, congruence, or getting into what does residual mean, which is very new for a lot of folks. Judy, any other comments?
My only question is, looking back at the chat, somebody said something about circles. I'm just trying to go back and see.
And there was just a question about, were these ratio activities available for the 84? And
oh, okay.
Those were built for Nspire, but in the middle grades math, there is some ratio and proportional reasoning activities in 84 Central, and you might want to look at some of those, and also in Algebra 1 when they've got some ratios, proportions, and equivalence activities there. And under circles, under Math Inspired, is that where you were heading, Judy, with the geometry?
Well, I'm not sure. I'm sorry, I wasn't sure what the question was. When Leslie asked, do you have circles? Leslie, can you?
Was it for graphing circles or?
Yeah, I'm not sure. Or, you know, I know that there, in the Common Core as well as the TEKS, there is a standard that says something about that circles are similar as well. And maybe that's what she meant. That particular activity does not cover circles with the similarity, but there are other ones out there. I hope I wasn't, you know, saying that something she didn't mean.
All right. Y'all have been great with the questions and great with the chat. Let me turn it back to Mike here so he can share some other things.
Thanks so much, ladies. So we are going to begin wrapping things up, and with the last few minutes we have remaining, if there are any additional questions that you have for Judy or Betty, please feel free to get those asked, and they'll do their best to get those answered. As promised, though, I know there was a few people asking about some of those atomic learning tutorials, so I'm going to share my desktop and take you to our website, education.ti.com, and if you hover over the Professional Development tab in the middle, and then scroll down to Online Learning. There's some really good stuff here, specifically there's technology tutorials on the right-hand side. The default is TI-Nspire tutorials, and again, these are from Atomic Learning. But also, if you're looking for maybe something for the 84 family, if you click on Graphing Tutorials, that next tab over, you can see there's a lot of Atomic Learning tutorials for instance, the 84C. So I'm just going to slide down so you can see just how many of these are already created. Again, they're free, so you can expand any of these as you wish and watch any of those nice short videos as many times as you want. I think Mark mentioned at the beginning, but today does wrap up our spring webinar series. We are excited that we do have a few webinars already lined up for this summer, late summer. So if maybe you're looking to get some more experience with TI-Nspire or TI-84 specifically, or maybe dust off some of the cobwebs that the summer created, please feel free to join us late July, early August for either or both of those two webinars as they might apply to you. Registration is open, so if you don't want to forget about when those webinars are, you can go ahead and on our webpage, go ahead and register for those webinars now, and you'll automatically get a reminder email. Each week, we've been giving away a free registration for a T-Cube summer workshop. This week's lucky winner is Gregory Williams. So Gregory, congratulations, and we'll be in touch in the next couple of days to get you a little more information.
Hey, Gregory.
Congratulations.
Yeah.
If you receive a certificate of attendance, go and click that link in the chat window. It contains the name of tonight's event. Also listed is a link for the documents that were used tonight by Judy and Betty. In case you missed any of this, have no fear. In a couple days, you'll automatically get a follow-up email that will have this information listed as well. So please be on the lookout for that as well. Lastly, we are wrapping up again the spring webinar series. And if you have any thoughts or any ideas or things you'd like to see in future online events, please let us know in the post-webinar survey. We'll gladly take those into account and see if we can do our best to meet your needs this coming summer and fall. So thanks so much, everyone. It's been a great spring, and we really hope to see you back online in a few months. Thanks again.
Good night.